We're live, I think, aren't we? Yeah, there we go. We're live. Okay, so review. Today, I'm going to do these on a separate sheet of paper. So I'm going to start with X. Yeah, there's a lot, so I got a lot of work to do. Okay, Pascal's triangle, right? Pascal's triangle. So I'm going to go 1, 4, 6, 4, 1. Great question. Every time I have a red pen, one of my students wants it more than me. So then my red pens disappear, but the one thing they never take is my color crayon, right? So my color crayon's always safe. So anyway, I'm going to go 1, 4, 6, 4, 1, because that's Pascal's triangle. We're going to go x to the 4th, x3, x2, x1, and no x's.
You can have my red pen.
You are awesome. And that's red?
Yeah.
Sweet. Thank you. Okay, you're awesome. And then on the 4s, we're going to go a 4 to the 4th, 4 to the 3rd, 4 to the 2, 4 to the 1, and then no 4s, right? And we're just going to put plus signs in between. Yeah, I like to use different colors. I think different colors are helpful for kids. So I just put the plus signs in between, and I cannot zoom this out, you guys. So I'll slide over. Once I start recording, it won't zoom. Okay, 1, 4, 6, 4, 1, Pascal's triangle.
Can you completely messed up?
That's okay. And then I've got the x4, x3, x2, x1, no x's. And then on the back end, I'll go 4 to the 4, 4 to 3, 4 to the 2, 4 to the 1. And we've done this enough times. We're starting to get good at this, okay? So if I simplify this, I'm going to have I'll write it smaller, 1x to the 4th. And you don't need the 1. You don't need the 1. And I'm going to go 4 times 4 is 16x to the 3rd. This is going to be a 16, and 16 times 6 I think is 96, but I'll double check. But 16 times 6, yeah, 96. 96x squared. That's a 64. 64 times 4 I think is 256, but you guys okay on how I got a 64? Okay, guys. So
I did get 256.
I think it's 256, yeah, plus 256x, and then 4 to the 4th is 256, okay? Okay, same problem tomorrow, but just a different number, okay? Just a different number, okay? Thumbs up?
Wait, can you go?
Yeah, I sure can, Natalie. How's that? Yeah.
Wait, is that 4?
4 to the 4th, yeah. And you know where that came from, Natalie? I'm going to show you. I want to show you. Because it's important you know. To the 4th power, right? Okay, to the 4th power. To the 4th power. So I go, you ready? I go 4, 3, 2, 1, none. Same thing, 4th power. I go x to the 4, 3, 2, 1, none. And that's the pattern, right? And then I've got Pascal's triangle in there, okay? Okay, so let's look at number 2. Okay, so we're going to use synthetic division, so I'm going to go -2 into my 3. Looks like I'm missing. Oh yeah, I am missing a term on this one, -3. Put a 0 there, a 4, and a -6. Okay, now where did the 0 come from? I'm going to show you where the 0 came from. Okay. Okay, there is a x to the 4th, x cubed, but there's no x squared term in this. There's a 0x squared term, so I have to fill in the spot where there would be an x squared term. So put the 0 in that spot, okay? So I've got 3, -3. I need an x squared term, so I put 0, 4, and then -6. I take the opposite of that, -2. And we're just going to do a synthetic division. The remainder goes there, okay? Ready for me to do this? So we know the first step. Thanks to Tamley, I have a red pen. Slide it down. So I get my 3, and I multiply, and I get my -6. But this is my add line, because we're adding a negative, Claire, right? That's why we made it the opposite sign, so we add a negative, right? So we're really subtracting, aren't we? Yep. -9. That times that makes a +18. I add, and I get an 18. Multiply and I get a negative 36. I add and I get a negative 32. I multiply and I get a 64, positive 64, which, what's that, a 58 I think? Positive 58. Okay, that's my remainder. Now, it's always going to be one less degree because we really did, even though we never saw the x's, we really did divide by an x plus 2. So if we divide by an x, it really does reduce the powers by 1. Natalie?
Where did you get the 36?
18 times negative 2.
Alright.
Got it, good. So my answer is a 3x cubed minus a 9x squared plus an 18x minus 32. My remainder, we go plus 58 over what we divided by. We really did divide by, even though it was invisible, x plus 2, okay? We really divide by x plus 2, so we go and bring it back. And of course, when you do synthetic division, all our x's are invisible, but in the end, we got to bring them back, okay? Okay, thumbs up. Thumbs up. Okay, let's look at number 3. Okay, 3, and again, I'm just going to keep working on scratch paper, so if you guys can, I got a 3x cubed times a 4x squared plus a 2x. This should be the easiest stuff, right? This times this times this. 12x to the 5th plus 6x to the 4th. Okay, 4 is going to be a FOIL problem. We've got a 2x minus 1 and a 3x plus 2. Okay, so we're just going to go 6x squared, 2x times 3x, plus a 4x, 2x times 2, minus a 3x, negative 1 times 3x, and a negative 2. Negative 1 times 2. The two middle terms can be combined because they're the same. They're both x terms. So the 6x squared plus a 1x minus 2. Okay. Slide it over. How am I doing, okay? Is my pacing okay? You'll tell me if I'm going too fast, won't you? You won't hurt my feelings. Just don't call me names. You won't hurt my feelings, okay? Number 5. 5 is big FOIL, but we can do big FOIL. 3x plus 2 times x squared minus 3x plus 4. Okay. 3x cubed, because 3x times x squared, minus 9x squared, 3 times 3, and x times x, plus 12x, 3x times 4, 2x squared, positive 2x squared. And I like to line them up. You don't have to line them up, but it makes it easy for me to add them if I line them up. Minus 6x, plus 8. Okay. If I add straight down, 3x cubed minus 7x squared plus 6x plus 8. Go ahead, Natalie. Ask, please. Always ask. Go ahead, I want you to ask.
Wait. Oh, wait. No, I get it.
You get it? Okay, good. Sometimes it just takes a minute to sit back and look at it, right? Now,
Hold up.
6 and 7 have plus and minus signs. They are not FOIL. Don't make the mistake. It says plus. So you're just going to add on 6 and on 7. We're going to subtract, right? So don't FOIL on 6 and 7. Okay. Slide over. Let's do number 7, okay? So number 7, if you take a look at it, you've got a 5x.
You skipped 6. Yeah, we do 6.
Oh, that's what I'm actually doing. Thank you. 6. 5x plus a 2x squared minus 4. Me make a mistake. That never happens, does it? 3x minus 2x squared. Okay, so don't FOIL. you do not foil. I'm going to use Tamley's cool red pen to circle that right there. That's a plus sign, right? That's a plus sign. So let's just add. So 2x squared minus 2x squared, they just cancel each other out. You guys agree? Boom, boom, they're gone, right? 5x plus 3x makes an 8x. And then the 4 is all by itself, minus 4. Okay? So that's it. I'm just adding like terms. That's all I'm doing is adding like terms.
Okay, do you want us to simplify it? Do you also want us to factor it?
Oh no, don't, no, leave it like that. If you want to factor it, that's fine. 4x squared minus 3x plus 6 minus a 5x squared minus 3x minus 5. Okay? So, you do not have to do this. I do, because I don't want to make a dumb mistake with double negatives. So I take, whenever I subtract, I take the negative and I push it through. Does that make sense? I bring the negative through so I don't mess up with double negatives. So I'll rewrite this as a negative 5x squared, positive 3x, and plus 5. It just helps me. Some kids are good about seeing the double negatives, and that's great. I just do this because I don't want to make a dumb mistake, because I am famous for making dumb mistakes. Right, Claire? Okay, or I should ask Katie, shouldn't I?
Yeah.
Okay, so these two are the same, right? So let's get a negative 9x squared. 3x's cancel each other out. Plus 11. Thumbs up? Okay. All right, now we've got p of x is equal to 4x squared. Oh, we're getting done. We're cruising. And if we don't get it done, then, oh well, that's what you guys do tonight, right?
Well. Yeah.
Okay, so Tamley did this on the warm-up and did a really nice job. Descending order, right? Put it in order, right? So we'll put that one first because it's got the biggest exponent. So I'll say p of x. Okay, in standard form is 5x to the fourth first. Then plus a 2x cubed. That's the next biggest. Plus a 4x squared. Minus, minus a 4x. Minus a 5. Okay, so put them in order from biggest exponent to smallest exponent. Okay, so there's 8. 9, our leading coefficient. It's right there, isn't it? There's my leading coefficient. It is 5. Totally right. Leading coefficient's the 5. 10, the degree. Well, the degree is 4. Yep. The degree is 4. Okay. That was 8. 9 is the leading coefficient. 10 is the degree. 11. We want the, how many zeros? Well, it's 4. Degree 4. 4 answers, but those are called the zeros, right? Those are called the zeros. So if it's degree 4, then there's 4 answers, or 4 zeros. Right? Whatever the degree is, that's how many zeros you have, right? Always. Even if they're imaginary, that's okay. And you will have some imaginaries tomorrow. Those are those darn I things, huh? Yeah. 12. So I'm going to use a calculator. I'm going to go 5 times. I'm going to let the calculator do the work, but I'm going to go negative 2 to the fourth plus 2 times negative 2 cubed plus 4 times negative 2 squared minus 4 times negative 2 minus 5. And again, I'm just going to use a calculator to do the work for me because I know I could make a mistake, and I don't want to make a mistake, so I'm just going to let the calculator do all the work for me, okay? Let's see if I can get this in a spot where you guys can see the calculator. There it is. So I'm going to go on, clear, 5 parentheses, negative 2 to the fourth power plus 2 times negative 2 to the third power plus 4 times negative 2 squared minus 5. And get an answer of overflow. What? Hate these new calculators. Let me get an old calculator. Alright. David's going to get it done before me, that's fine, David. Let's see if we get the same answer. Let's try it again. 5 times negative 2 to the 4th plus 2 times negative 2 to the 3rd, 4 times negative 2 squared, minus 4 times negative 2 minus 5, 83. Did you get 83? Okay, 83. So, from x equals negative 2, that comes from an x plus 2, right? That comes from an x plus 2, right? So that means if I were to divide by x plus 2, the remainder would have been 83. Okay? And x equals negative 2 came from an x plus 2, right? If you were to solve it backwards. So that means if I divided by x plus 2, it wouldn't go in evenly. We'd actually have a remainder of 83. Now, Nell, you know this answer. If it was what, we'd say yes.
0.
Then we'd say yes. If it's anything else, we say
No.
no. So is it a factor? No. Right? It's as easy as that. 0 means it goes in evenly, no remainder. Anything else means we have remainder and it can't go in evenly, okay? Okay, 14. You guys ready to do 14? No? Okay.
That was 13.
That was 13. Yeah, so we'll do 14 in a second, okay? We'll do 14.
I think
We should what?
Yes, take the test on Friday and tomorrow is a
No, can't do that. I'll tell you 2 reasons. One, first and second period, we're going to lose kids for Snowy Owl, and I'm not going to go through another test where we're missing half the class. And the second thing is, we're ready for the test, and I want to do something fun on Friday. We're gonna start building rockets on Friday.
For what?
You don't want to build rockets? They're kind of fun. Wait till you see them. Anyway, well, these won't blow up unless you are afraid of water. Then that's the only way they're gonna blow up. Okay?
Are these air rock, water rockets?
Yeah. Okay, 14. Anyway, let's do 14. 5x squared minus 7x. Okay, so we're factoring. What do you think? We're factoring. Okay, Claire says that all they have is a common x. 5x minus 7. What's that? No. 13 was no. 13's no because we got a remainder of 83, not a remainder of 0. Yeah, does that make sense? So if you look at the answer to 12, the answer to 12 is 83, which means you got a remainder of 83, not 0. So it does not go anywhere. Okay? Are we okay with 14?
Yes.
How about 15? Okay, I got a x squared minus 49. Right? What do you guys do? You know this, don't you? Yep. Who said that? Who is a smart girl back there? Smart girl. Oh, yeah. 16. 16's a little harder, but we can do it. 2x squared. Oops, 2x cubed, my bad. 2x cubed minus 4x squared minus 16x. Okay, anybody have any brilliant ideas?
I did it.
And a 2. You're totally right, David. Let's take out a 2x. And let's see if that makes it any easier for us, okay? Can you see how they all can be divided by 2x? So I'd have a x squared minus a 2x minus an 8. I think that could be done again. Multiples of 8. Negative 8 to make a 2? Sure. How about an x minus 4 and an x plus 2? Mm, 17. X cubed minus 125. Oh, it's one of those x cubey things, and I erased it, but I'll put it up here on the board here in a second, okay? That's the same thing as an x cubed minus a 5 cubed, because 5 times 5 is 25, times 5 is 125. Now, what I want is the a cubed minus b cubed, okay? So a little side work here, so you guys see a little side work. That factors into an a minus b, a squared plus ab plus b squared, right? And then you don't need to memorize this formula, but that is it. And I can even put it back on the board if you want me to tomorrow, okay? So then this is going to factor into a is going to be my x, and my 5, so I'm just going to put x and 5 into my formula. So I'm going to go, okay, x minus 5, x squared plus 5x plus 5 squared, which is 25. Okay. Not too bad, right? Not too bad. 18, we have x cubed plus 2x squared plus 5x plus 10, okay? 4 terms. Group it. 4 terms, do it by grouping. Let's put these two together and these two together, okay? They have a common x squared, okay? These two have an x squared in common. I would have, if I pulled out the x squared, I have an x plus 2. And again, you can check it because you do know x squared times x is x cubed. And you know x squared times 2 is 2x, okay? These two have a multiple of 5 in common. If I common factor out of 5, I'd have an x plus 2, right? Tamley's going to put the phone away, aren't you, Tamley?
Yes, sir.
Thank you, Tamley. So now these two groups have in parentheses x plus 2 in common. And I like to cross them out so you don't get confused. I pulled it out. By writing it once, it represents both. What would be left is an x squared plus 5. Okay. Okay, 19. I'm going to use a calculator to do 19. Okay. I'll wait for you. So if you don't have a graphics calculator, that's okay, but you're going to need one, okay, to do 19.
Millions of times we have
Y equals, and I'm going to do the x to the third plus 7x squared minus 2x.
Mr. Davies, we can't see it.
Oh, I hate this calculator. Never mind. I hate this calculator. Okay, let's go and do. Okay, y equals. I like the old ones better. Yeah, Katie, I do need your help. Okay, so y equals. Thank you, Katie. Oh, I got a scatter plot. So let's turn that off.
Wait, how do you what?
Oh, I had a scatter plot. Don't worry about it. Okay, so I'm going to go x to the third power, right? Plus 7x squared. Subtract 2x. Subtract 14. Now, before I do a whole lot, let's use a little common sense on my window. I've got a negative 14, right? So I know for sure on my y min, I got to go at least down to negative 14, okay? So I check my window. Negative 6, that's probably okay. But I'm thinking probably maybe negative 20, and I think I'm going to go 10, okay? And I could be wrong. I could be way off. And if I'm way off, I'll just adjust it according to the picture, right? Does that make sense? Thanks, Stephanie. So if I graph it, boom. Okay, now, is it coming back down? It's an x cubed. It might come back down. So I'm thinking, just out of pure common sense, that I might want to go further this way. So let me go to graph. Let me go to my window. Let me make it go to say. I'm just going to try 10, see if I see anything. Negative 10 and 10. Okay. David says try negative 10 to 10. Oh, thank you, David. So I played around with it.
Davies, what was the other window?
Okay, here we go. Window. So I played around with it a little bit. David, you found it, negative 10 to 10. And then I still need to go, I think, down a little bit, don't I? Or no, up. I got to go up a little bit. So we'll take a look at what I have. Graph. So probably up on the Y's, right? Up on the Y's. What do you think? David, 20? Should we try 20 there? Higher than 20? Want to go 30? Let's try 30. David says 30. Oh, even higher than 30, right? So you just got to keep... Okay, let's try 50 then. Let's not mess around. Let's go to 50, okay? I think somebody said... It's higher than 50?
Higher than 60.
Let's try 100, right? Let's overshoot it. I think somebody yesterday said just put it really big. Higher than 100?
Yeah.
No. I got it at least 100.
I'm higher than 400.
I got it at 50 and it worked.
I'm higher than 400.
Check your equation. Check your equation.
No, it's higher than 1,000.
Check your equation.
No, my equation's right. It's over
Are
400.
they trying to find
You
this?
only need 3.
Not mine.
Yeah, they're not, they're.
Let me see your equation. You can't be.
No, they're looking for this.
But that's not a thing.
That's
This is it.
That's good.
Oh, I don't care about that.
No,
Okay, now.
no.
Okay, real quick. All right. And David, let's make sense of this. Okay, let's think about it. Here's what we know. Okay. Okay, before I even graphed it, you ready? I knew it was a cube, right? You guys agree?
Davies, we can't see it.
Okay, before I even graphed it, I knew it was a cube, so I knew it had to look something like this. And remember we talked about end behavior? David, you with me?
Yeah.
Remember we talked about end behavior? I knew that at this point it's going to just take off to infinity, right? Because of the pos of x cubed. And so I once I got that and that, I knew I was done, right? I knew it was done. So then we can get the max and the min by using the calculator. Let me go through that again with you. So I'll go calculate maximum, and I can get that by, over there, enter, and enter, and I can get the max, and I can get the min. And you guys know how to do this, right? We know how to get the max, we know how to get the min. Okay, so let me move on. Let's do 20 and 21. You guys okay with that? 20, 21? Let's shift over to 20, 21. Number 20.
Wait, it tells you just to find the x and y intercepts though.
Oh, well that was easy.
So you don't even need to find the maximum.
No, you don't. No. Yeah. And you get the x-intercepts by using the 0 button, the 0, right, the zeros, or factor. And if it doesn't factor, actually that one will factor, won't it? That will factor, so you can get the x-intercepts. I'm going to go back to 19, just real quick. No, I'm going to go back. So if I want to get the x, I already know the y is negative 14, right? Okay, so I already know the y-intercept is at, right, everybody get that? Y-intercept, right? Natalie's shaking her head, no. Natalie, if x were 0, what would be left with? Which is just the negative 14, right? No, Natalie, you ready? So to get a y-intercept, let x equal 0, and if x equals 0, negative 14.
Wait, where's this? Okay, that's cool.
So now, if I factor x squared, x plus 7, negative 2, x plus 7, right? If I factor again, mini equations, you can see we're going to get negative 7 as one x-intercept, and plus or minus the square root of 2 is the others. Now you good? You got it. Okay.
Yep.
Okay, good. Thanks, Claire.
Were you saying like you put the x into the rest of it like as 0 for x and then like
0, 0, 0,
alright,
negative 14.
I got you.
I knew you would.
Thank you.
Okay, you're welcome. Okay, now tell me when you're ready for 20. Thanks, Claire, for clarifying that question. I can't help myself. Sometimes I'm just way too funny. Yeah, right. I can't help it. Yeah, he's a pretty funny guy. Yeah, his jokes are pretty bad, aren't they?
Yeah, they are.
Yeah, they're terrible. Okay, 20. Yeah, the Muffin Man. Has he told the Muffin jokes for a long time?
He tells a bunch of band
Oh, I'm talking about Massey. I thought you meant, yeah.
Massey tells muffin jokes?
Oh, he hasn't told the Muffin jokes for a long time, huh?
I'll have to ask him.
Muff Man. Okay, so bring that over.
That's fine.
5x cubed minus 10x squared minus